Yo, 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 yo. All right. 7.3 multiplying special cases. So, um, key term is difference of squares. Let's get that down. We'll show an example of what that is a little bit later on. These special cases, these are kind of like shortcuts that we're going to learn today. They do help us later on if we understand this pattern because it'll make another section later much, much easier for us. So it's just recognizing the patterns, and but worst case scenario, they really are shortcuts. So I'll show you what I'm talking about. So if I look at something like this, a plus b, and I have all of that squared. So I'm taking a binomial right here, and I'm squaring it. It is a special case, and here's why. If I did distributive properties, so if I expanded this out, a plus b squared is really just saying take a plus b and multiply it by a plus b again. We're multiplying it by itself. Well, if I do this and I do distributive property, I get a squared plus a times b, right? A times a is a squared. A times b is a times b. I'm going to multiply b times a. Well, that's a times b again, right? And then I also get b squared. Well, whenever we do this, we're going to get the same pattern every single time. We're always going to end up with this first term squared in the beginning. Whatever this last term is going to be squared in the end. And then we just multiply these two values, and we have two of those. So it's going to be times 2ab. This pattern will happen every single time we're squaring a binomial like this. Okay, where we're going to have the first term squared, the second term squared, and then we're also going to just have 2 times the product of those two values. This is a formula that we get to use. Okay, this is called the square of a binomial. Now, that being said, here is that formula that'll work pretty much every single time. And that's kind of, again, just like a shortcut, so you don't have to multiply all the time or multiply everything. So, like if I looked at this one right here, this is going to be, there's another way of writing this. So this is 5x, I want to write it as addition, so it follows this, plus negative 3 squared, negative 3. So I just rewrote it a little bit, or I rewrote it where now this is addition, because then I can kind of follow this pattern right here. Okay, so I could expand this out. I could do 5x minus 3 times 5x minus 3 and do distributive property. Or what I could do is I could just square the first term. Well, that's going to be 25x squared. Square the second term. Well, that's going to give me positive 9, because negative 3 times itself is positive 9. And then I do 2 times 5 times negative 3. Well, 5 times negative 3 is negative 15. And I got to multiply that by 2. Well, negative 15 times 2 is negative 30. And there's the x. I'm done. So I just did a quick shortcut without actually doing distributive property. Okay, so I squared the first term, squared the second term, and then I just multiplied these two guys. 5 times 3 is negative 15, then I multiply that by 2 because I'm going to do that multiplication twice. Now, we also have a specialty, or a special case, when we multiply products that look like this. So let's see what this one looks like. So now I have a plus b and a minus b. So this is not a plus b squared. This is a plus b and a minus b. So if I look here, let's do distributive property here. A times a is a squared. A times negative b is negative ab, because now it's negative because I have a negative b right here. Well, now if I do b times a, that's positive ab. I then need to do, so after doing b times a, that's positive ab, and then I need to do b times negative b. Well, that's going to give me negative, and then b times b is b squared. Positive times a negative is negative. B times b is just b times itself, with this b squared. Well, if we notice this, what happens is negative ab and positive ab, those are the same exact things. Those cancel each other out. So I just get a squared minus b squared. And that is a pattern that'll happen every single time. So if you have the same two values, but they're being added and subtracted and you're multiplying them, it's always just going to take the first term and square it, take the second term and square it, and you're going to subtract those two. So looking at that, this would be an example. I have 5y minus 1, 5y plus 1. Same values, 5y and 1, and then I'm adding and subtracting them. So the pattern shows me that I just take this first term and I square it. Well, 5y squared is 25y squared. 1 squared is 1. So that's 25y squared minus 1, and I'm done. There's nothing else to do here. That's it. Okay. I could use distributive property to multiply this out. That's totally fine and that works, but it's just not necessary if I know this pattern and I'm able to do this shortcut. Okay, so here a graphic designer is developing images for icons. A square pixelated image is placed inside a border. So we have the white square inside the border, and then we have the border, which is the red border. Okay. The border that is 2 pixels wide on all sides. So this border is 2 pixels wide on all sides. That means from here to here is 2. 2 pixels wide on all sides. Okay. If the area of the border of the image is 176 square pixels, what is the area of the actual image? So the border itself is 176. I want to know what is the area of the image. So here's how I'm going to set this up. What I'm going to do is I'm going to set up the area of everything on the outside. So the whole border is x plus 4 squared. Because this is x plus 4 from here to here. This length is x plus 4 from there to there. Problem is the border is hollow, right? That's just the area of, that's just for the border. But we got to subtract the inside area because the area of the border is not including the inside part, right? Because remember, the border is just for the outside. This picture is the other part of it. So the border itself is all of this minus whatever the area of the picture is. Well, the picture has a side length of x right here. Well, and the house has a side length of x right here, so that's minus x squared. And I know that this is going to give me the area of the entire border. Because I'm just taking the area of the outside part, which is all of it. The whole square right here is x plus 4 plus x plus 4, but I got to subtract this piece of it to get the area of the border. Well, I know that area is 176. So here's my equation. Now what I can do is I can use our shortcut real quick if I wanted to for x plus 4 squared. I know that's going to give me x squared. I know it's going to give me 16 because x times, I know when I have a square as a binomial and I'm squaring a binomial, I square the first term, square the second term, and I just multiply the two terms, which is x times 4, which is 4x, but I multiply that by 2. That's 8x. So that's what this simplifies to. Minus x squared equals 176. Now I can solve the equation because minus x squared, those cancel. I get 8x plus 16 equals 176. Subtract 16 on both sides. 8x equals 160, so then x equals 20. So I figured out that it's x equals 20. What that means is that every side of this image is 20 because I'm just replacing x with 20. So 20 pixels. And now if I take that, that's 20 plus 2, another 2. That means the whole thing is 24 pixels. So now that I know that this is 20, I know that the area of the image is 20 times 20 because it's a square, which is 400. Okay. What I want you to do is pause it, see if you can use a shortcut on your own to simplify this difference of squares. So this is an example of the difference of squares. See if you can simplify this one. Pause it, try it, see how it goes. Okay, so again, because I have the same two terms, doesn't matter there's a y there, it doesn't make a difference. It follows the same patterns. I have the same two terms, 2x and 9y, and I'm adding and subtracting them. Well, I take the first term and I square it. 2x squared, well 2 squared is 4, x squared. Take the second term and I square. 9 squared is 81, and then y squared. And I subtract them, and I'm done. So that's 4x squared minus 81y squared. Now, you can use a difference of two squares to find the product of 43 and 37, or different whole numbers as well. So if I did 43 times 37, but I wanted to use our pattern, I got to set this up as the same number plus and minus the same number. Well, I can rewrite 40 as 40 plus 3, and I can rewrite 37 as 40 minus 3. 40 plus 3 is, this was simplified to 43. 37 would be 40 minus 3, that's 37. But now I have the difference of two squares. So I can square 40, which I can actually do in my head is 1600, because 4 times 4 is 16, and 2 zeros. Well, then I can square 3, that's 9. So 1600 minus 9 is 1591. And I'm done. Okay, that's it. Nothing in the things to remember. Here's your independent practice. Get it done. If you guys have any questions, let me know. Radius out.